Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem squares of a sorted array. But before we begin, if you've been liking these videos, please subscribe to the channel. When you subscribe to the channel, it lets me know that you want me to make more of these videos, and as a result, I'll make more of them. Also, another note is that this video is part of the 2 pointers playlist that I have created. So if you want to watch other videos talking about how to solve Leetcode problems using the 2 pointers coding pattern, look in the video description. There's a link to the playlist to see the videos I've created to do that. All right, so the problem says, given an integer array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. So when we look at the example array, we see that it's sorted in non-decreasing order, and then we're to square these, and then we're to sort these so that it ends up having the result of this. Let's go take a look at the constraints really quick before we dive into some thoughts about solving this problem. So in the constraints, we see that the length is between 1 to 10 to the 4, so we know that we're guaranteed to get an array that has at least one element, so we don't have to check to see if it's null or not. Next, we can see that the values inside the nums is between negative 10 to the 4 to positive 10 to the 4. It's good for us to look at that because we're going to be squaring these numbers, and we want to make sure that after we square it, it'll fit inside of the array that we're going to use. So when we square these numbers in this range, it will still fit inside of an integer. So we're safe to have an integer array. Next, the nums is sorted in non-decreasing order, so that's guaranteed. So because it's already sorted when they give it to us, then when we have to return a sorted result, we can make use of the fact that it's already sorted to be able to do our sorting faster than n log n. So in other words, if you were to give me an array that wasn't guaranteed to be sorted, and we did this problem, then if I was going to sort it, I would have to use a sorting algorithm. And like in the, excuse me, what I mean is I would have to use collections.sort, or, in Python, I'd have to use the sort library, and that's n log n, because that's just a generic sorting algorithm that's going to take numbers that have no type of sort or special scenario involved with them, and it will always sort it, no matter if there's no preconditions. It's just an array of numbers. It'll sort it, and so that algorithm is going to be n log n. But for us, we know that this is a special group of numbers that we're dealing with. This group of numbers is already sorted in non-decreasing order. After we square it, it's going to not be in non-decreasing order, but before it was in non-decreasing order, because it was in non-decreasing order beforehand, we can make use of that fact to come up with an algorithm to sort it faster, and we could do it in linear time. Okay, so let's look at this problem. We'll head over to the blackboard, and then we'll figure out how to solve this problem. Here's the problem from example 1. So the first thing I'm going to do is share my thought process when I solve this problem, and then next I'm going to show how to solve the problem. So my thought process when reading this problem is that there's a constraint in there that says that the input array is going to be in non-decreasing order. So that stands out to me, that there's potential there for me to be able to do the sorting faster than what a generic sorting algorithm would do. So generic sorting algorithms like merge sort, quick sort, which is what your programming language libraries API will use, those work to sort with any type of numbers that don't have special constraints. The time complexity on those is n log n. In our scenario, our array that we want to sort has a unique constraint to it, that it is already sorted. And so I know I'll be able to make use of that to be able to sort it faster than n log n. I'll be able to sort it in linear time. So let me show real quick, like if Once if we were to square all these, then it's still sorted. It's not in non-decreasing order anymore, but there's still a sort to it. It can, it's the sort to it is that, look at this. It's greatest to least down here, and then from least to greatest. So that's a sort. It's not ascending. It's not descending. It's this. There's probably a name for it, but it's sorted in its own unique way. So I know I can make use of this to do it in linear time because look at this. Like if I had, let me copy this real quick. Just copy all these real fast and go like this. So if I wanted to decide like what the highest number should go here, well, I know the highest numbers are at the ends of this array, so I just pick the highest between these two, and that would be 100. And then now I'm going to pick the highest between these two, and that would be 16. Okay, so this is pretty obvious that I can do the sorting in linear time complexity. And if it's not yet, it'll be crystal clear once we start solving the problem. Okay, so the next thing I start thinking to myself is, am I going to do this in place where I modify the input array that they passed in, or am I going to create a new array and put the result in that? Well, the problem doesn't say that it doesn't ask me to do it in place. I could ask the interviewer, is it okay if I create an extra array, or do you want me to do it in place? And they in this problem, they might say like, yeah, it's okay if you create another array. Or they might want to test your knowledge and say, can you do it in place? And then you can start talking about that. Well, when I look at this problem, I want this overall problem to be in linear time complexity. And when I start thinking about doing it in place, I start thinking like, how can I do this with just constant time complexity? And I think to myself, can I swap? No, if I do swapping of the original array, that's gonna mess up the order. And I'm just not seeing a way to do it in place. If you know of a way to do it in place with linear time complexity, please tell me in the comments. So I'm not saying to do it in place, so I'm going to do it with an extra array. So I'll start with this extra array and I'll zero these all out. Okay. And then next, I know that the ends are where the greatest numbers are. So I'm going to put 2 pointers. I'll have left, and then I'll have right. Okay, and then I'm not going to modify the input array I said, so I'm going to create 2 variables to hold the values. So I'll call it left pow and right pow. Okay, so when we do this, the left pow will be 16, and then the right pow will be 100. And then since I'm working with like the greatest value, starting with the greatest values, I'm going to start at the end. This is going to be easier to do it this way because we already know the greatest values are at the end. So why don't we just start there, and then we'll update the array from the back to the front. Yes, we could do it a different way. We could figure out where the center point is and then work out from here to there, and then we can go from the beginning to up. But why? Like I would have to do more work to find out that center. It's already sorted, and I can just put left and right at the ends. So let's do that. It'll make the code cleaner. Okay, so now I'm going to look to see which one's greater between these two, and I see 100 is greater, so I'm going to put 100 here. And after I put that there, I move that down, and since I chose 100, I move this one down. And then I re-square these, so 16 and 9. Now I say between 16 and 9, which one is which one is greater? And so I see that 16 is greater. So I'll put the 16 in here. And then I'll move that up. And then I'll re-square everything. So I've got the square the left and square the right, 9. Which one's greater? The 9's greater. So, and this moved down, by the way. And so do the 9. This moves down, and that moves down. And then we have 1 and 0. And so the 1 is greater. This moves down. And then this moves up. And then we have 0 and 0. And so I put the 0 in there, and then this moves down. And now that is less than the index 0. So we are done, and then I return this result. Okay, so that is how we solve it. So we will go code it up. We'll start with Java, and then we'll do Python next. Okay, so first I create that array that I'm going to return. Okay, and then next I'm going to create that left, say, so the left pointer, and then the right pointer. And then in here I'll do my for loop. Okay, and then these I could put them in here if I wanted to, so maybe I'll just do that because I don't need them outside the for loop, so this will look a little bit better. Maybe not look a little bit better, but it'll be clear to the next software developer that these aren't needed outside of the for loop. Okay, which is good code maintenance. It's good to see how I'm talking about it. Like that's good to do in an interview. You just tell them like your thought process, why you're doing things. All right, so we have this left pal and we have this right pal, and then whoops. Okay, now is the check. Like, is the left pal greater than the right pal? Yes, it is. So then, in result of I, we will put in the left pal. And then we also need to move that left pointer. And then if it's less than or equal to, then the result of I equals the right pal. And then the right goes down. Okay, so if I was in an interview, I would have more than just one example to test my code out. I would test the edge cases, probably come up with like maybe 4 different case scenarios. And so let's look over it. I mean, it all looks good. Everything's looking good. Okay, so let's run it. Yeah, nums. So the last problem I solved said R, so I was thinking R in my mind. Oh, and I didn't do these ones either. Oops. Okay. Okay, and then now I'm going to submit it. Okay, great. So that was accepted. So now we'll head over to the Python. All right, so for the Python, just say result equals 0 times the length of nums, and then left equals 0, right equals length of nums minus 1, and then we'll say for I in range of length of nums -1, -1, -1. Okay, so we're going from the end to the beginning. We're looping from the end to the beginning, and we set left pow equals pow of nums of left to right pow equals pow of nums of right to if left pow is greater than right pow, then result of I equals left pow left plus equals 1 else result of I equals right pow. Okay. Indentation error. Okay, I think the problem is some lines have tabs, some have spaces, so we'll just remove the tabs with spaces for that line, run it. Okay, it was accepted. All right, so if you like this video, please subscribe to the channel. When you subscribe to the channel, it lets me know that you want me to make more of these videos, and as a result, I'll make more of them. And please take a look at the video description. You'll see in there that there is a link to a playlist where there's more two-pointer problem videos that I made. And have a good day, and I'll talk to you later. Thanks, bye.